previous example, we looked at set covering and assignment together with the total distance to be minimized. And here we're going to look at a similar problem, but we will now try to maximize profit. Once again, we have set covering problem as well as an assignment problem combined. But there are some differences here. Now suppose we have manufacturing facilities that we can operate in these cities. Okay? And in each of these cities we have orders that are available that we can pick up. Okay? There is the customers have offered a price of these total for these quantities. Okay, so these are not unit price, this is the total price for these quantities. So we can either choose to satisfy the order and make that price, or we can say we don't want to select that quantity and we will leave it. Okay, so this is what we need to decide. We need to decide which of these orders we will fulfill. Yeah. So which means if you want to fulfill these orders, okay, we need to then set up factories in any one of these plants, one of these cities. And if we did, then we have to then offset the price of production and price of transportation from this price, and that will give us the net profit. So there are two changing cells, like whether we're going to locate plants in these cities or not. If we did, which of the orders we will assign to those plants from these. Okay, so that's the question. Okay, so let's go to the Excel file. So here are the inputs. So production cost, shipping cost, monthly fixed cost, and plant capacity per pound. So let's look at this a little more closely. So if we produce quantities, so this will be the production cost per pound. If we ship, for example, if we assign the order quantity of Chicago to Boston, then Chicago to Boston, the distance is 983 miles times 0.02, that will be the shipping cost. And if we locate a plant, if we operate a plant in any one of these locations, it's going to cost us $60,000, and you can produce only up to 2,500 units. So that's the distance, and these are the quantities and price available in each of these cities that we may either choose to satisfy or not. So whether we're going to operate a plant or not, that is a changing cell for us, 0, 1. Okay. If we operate a plant, are we going to ship from, so this is the customers along the side and the plants along the top. So are we going to assign a particular order, okay, this is the customer, particular order to a given plant if the plant is located. Okay, so our logical, the pounds shipped out or not is, okay, if an assignment is made, then the pounds will be shipped. So let's give names here. So if we did a sum product, okay, here is where the assignment is going to be made. Okay, and that's the quantity. If the assignment is made, then that quantity will get picked up. Okay. Now of course the logical capacity is, if a plant is, let's give a name here first. Okay. So then 2,500 is the capacity if a plant is operated. If you open a plant, then there will be that capacity, otherwise 0. So this should be less than or equal to. If a plant is not located, then no assignment can be made for that plant. We cannot assign in order to more than one plant. So you have to sum across like this, and we need to set it to less than or equal to, allowed is 1. You shouldn't set it equal to 1, in which case you're forcing the order to be accepted. You shouldn't make it greater than or equal to 1. That doesn't make any sense. So this is sum and required. Okay, and this is what we did in the previous problem too. So this will make sure that an order, if it is picked up, is assigned to only one plant. Okay, next we have to set up the monetary output, revenue minus production and shipping cost. So here, if an assignment is made, if this is the customer, that's your plant. So if a customer's bid is accepted and assigned to this plant, what will be the monetary outcome? So we start with the revenue, and as you copy this revenue across this way, the revenue column shouldn't change from M to N, N to O, and so on. But when you go down, the different customers must change from 11 to 12 and so on. So it should be $M11. Okay, that's our revenue minus, we have the cost, and there is two costs. Both depend upon quantity. So let's get the quantity, and that should be absolute referenced as well, like that. Okay, times, okay, there are two costs here, so you have to start a parenthesis. Okay, one is cost of production, so per pound, so that times the quantity will give you the production cost. Okay, plus shipping cost, okay, times the distance. Okay, distance is given in this matrix. Okay, and that again must be multiplied by the quantity. So this is your production and shipping cost per unit, and then that's our number of units. So this will give us the monetary outcome or profit if a plant is located in Boston and the assignment is made for Boston into Boston. Okay, so either we can set this up this way and then do a sum product with the assignments, or we can multiply this with the 0,1 variable, which is what your textbook has done. Okay, so let's do it in this fashion. So this is the possible outcome, monetary outcome, if an assignment is made. Okay. All right. So now the fixed cost, monthly fixed cost, will be the sum of. Okay, let's give a name here. This is assignments made. So fixed cost will be sum of plants that are opened, okay, times the monthly fixed cost. Okay, total profit then is sum product of the assignments made with the corresponding monetary outcome. Okay, So that is going to be net of before fixed cost. So we have to now net out the fixed cost, which is that. Then that would be our total monthly profit, which must be maximized. So that's our objective function. We'll give a name here. And let's put a box around it. Okay. So let's give names here. Pound shipped out, logical capacity. And then we have the sum. All right. So now let's run solver. We want to maximize that. Changing cells will be that, comma, that. Okay. Constraints. Pound shipped should be less than or equal to logical capacity. Sum should be less than or equal to 1. Okay. Whether we're going to locate a plant or not should be binary. And whether we make an assignment or not should be binary. Okay. Non-negative. Simplex LP. Going to options, make that into 0. Solve.